Okay, so this is part 2 of the video. So you should have cut out and matched the scenarios with the graphs, and you should have submitted the assignment on Schoology. That assignment just is for yourself to see how you're doing. If you missed a lot of them, then you know that you need a lot of work, and then it also shows me how we're doing on it so that I know um, where we're starting from. Okay, so I'm going to go ahead and I'm going to use my highlighter and I'm going to highlight the important pieces of this and then show you the graph that matches. So it was 75 feet above the river, so you know on the graph it needs to start up high, and then he's going to jump, or he's diving off, so he's going to be going down, and then he went 10 feet into the river. So this graph is actually E, graph E. He starts high, he's jumping off the cliff. You wouldn't want him to go straight down, that would not be good. So he's jumping off the cliff, and then he hits the water and slows down, of course, because you don't hit the water and keep going at the same rate, and then is going to go underwater. Okay, so this is graph E. And while we're on this one, we'll go ahead and I'll write out the independent and dependent quantity. So in this, you always want to look for units. So the units that we're talking about, and I'm going to use a different color, are feet and seconds. So those are our 2 units. So that tells you what 2 things we are comparing. So those are our 2 quantities. Notice if you look over, or even here, it says independent quantity. So a quantity is like a unit. Sorry, you can hear my son in the background. He's working on school. And I think playing a little bit. But so feet in seconds. So the feet above the river, does that depend on the time since he jumped, or is it the seconds depend on the feet? So it's definitely the height, and the height is, we know, in units of feet. And then the independent is time, which is represented in seconds. Okay, so the time is independent. You can't change time. The dependent is the height. So the height above the water depends on how long it's been since I jumped in the water. So I'm going to just quickly glue this in so that I have it in there, because we now know that one's right. Okay, it says to do a scale, but I just want you to say this has to be 75 and this would be 0. We know it took him, he went 10 feet underwater, so -10 somewhere. So down here is -10. And then this is actually, this took 1.5 seconds, so 1.5 seconds to hit the water. Okay, make sure you label this as height. I messed that up. Let me mark that out. So height, and then this is time. So along the x-axis is time, along the y-axis is your height. Okay, let's move to the next one. So independent and dependent quantities, but first let's figure out what we're talking about. So we have a 200-gallon aquarium, and they're draining the water. So that means it's going to start with 200 gallons, and then it's going to go down. Okay, so we're going to, let me find it, there it is. So this one's actually graph H. Notice it started at 200 gallons and then it's draining. Okay, and water drains at a constant rate, and we talk about this later on, but since it's a constant rate, it's going to be just a straight line. There's no change in it or anything like that. So I'm going to glue this one in. Okay, look for your 2 units. So we know we're talking about minutes. It was 10 gallons per minute. So if you're talking about a pool, is it the gallons depend on the time or the time depends on the gallons? So is it, so it's definitely time again is independent. And this time our unit is minutes, and you can put min. And then our gallons depend on how long it's been since we started draining the pool. So it would be number of gallons. Okay, go ahead and label your graph. So we would have time and number of gallons. Cannot write sideways. So, and we know it started at 200. Okay, the next one is B. Oops, I dropped B and I don't know where it went. Oh, it's way over there. Sorry, guys. So you're going to upgrade a smartphone. You do not have the money to purchase it. Your cousin will provide the funding as long as you pay him back with interest. He tells you that you only need to pay $1 in interest initially, and then it's going to double. So this one is a little harder. You probably haven't talked about problems like this before, but so if we start, and here's our $1, then it's going to become $2 because it's doubling each week. So 1, 2, 2 doubled is 4, 4 doubled is 8, 8 doubled is 16, 16 doubled is 32. So notice this is called, we'll get to it at some point, but it's growing exponentially. It's doubling, 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 doubling. Okay? The only thing I'm going to do from here on out is I'm going to give you the graphs and give you a little bit of an explanation. I'm not going to identify the independent and dependent. I want you to do that. And then if you have any questions, of course, email me or ask me or whatever. Okay? All right. So the next one, can't wait for the slopes, or what is it? Yeah, can't wait to hit the slopes. So this one is going to be G. This one's G. So if you look, it says Andrew's using a GPS on his phone. It moves at a steady rate of 400 feet per minute until it suddenly stops. So it's rising to 400 feet, stops, so that's why it's right here. So time is still going, so you know time is your independent. Time is down here. And then this is the height or the altitude. So notice the height is not changing, but the time is still going. So he's still at 400 feet here. And then it calls his friend to tell them that he is stuck. They talk on the phone for 10 minutes until finally the ski lift begins to move again. So he was going. The ski lift stopped working. He called somebody. They got it fixed here, and then it started going again. So, and this is height. And this is in feet, and you can see feet right there, and minutes. Okay, so make sure you put your units on those. Okay, its magic is D. Okay, so if you look at this, where's the part? He begins the trick with a 20-foot rope and then cuts it in half. He then takes one of the halves and cuts the pieces in half. he repeats this process. So this is the opposite of this one. So notice this one's going up by doubling. So this one, let's say, or it started at a 20-foot rope. So then he's going to cut it. So that would be 10 feet. And then cut it again, and that's 5 feet. Cut it again, that would be 2.5. Cut it again, and that would be 12.5. Or, sorry, 1.25. Okay, so this one is the opposite, where this one was growing or doubling. This one, he's cutting it in half. Okay, so the things that we're talking about is cuts the rope. So cuts the rope and then the length. So is it the number of cuts depends on how long the rope is, or is it the length of the rope depends on the number of cuts? So the length of rope depends on, sorry, I didn't need to write that. Depend on the number of cuts. So the number of cuts would be on the x-axis, and the length is on the y-axis. Okay, a few more. We have the contouring. We have F. And this one, I'm going to do a little bit less help. Again, let me know if you need more help than I'm going to give you. But so it reaches a maximum height. So throw it, it reaches a maximum height, and then of course it's going to start coming back down. Okay, cold weather is graph A. So notice if the temperature, oops, sorry, something just popped up on my screen. If the temperature is going up, oops, you couldn't see it. So if the high temperature is negative 200 or negative 20 degrees or below, no one comes to the resort. As the temperature increases, so does the number of guests. Once the temperature reaches 0 degrees and increases through the single digits, the number of guests soar. If the temperature is 10 degrees or higher, the ski resort will hit a capacity. So your two things that you're talking about are the number of guests, so the number of guests, and the temperature. So as the temperature gets higher, the number of guests increase until we hit a capacity. Okay? The jelly bean challenge is C. Okay, so, and we actually do this activity whenever we get to this type of graph, but so if you're doing the number of guests, and say I guess that there were 10 jelly beans in the jar, and there were actually 12, I would be 2 away from it. So the possible number of guests until you get it correct, and then you're only 0 away. But if you're on this side, you were 1 away from the jelly beans. This one you were 2 away, 3 away, 4 away, 5 away. So this would be your, where is it at? So we have number of jelly beans. Guessed, sorry, I was looking over, I cannot think to spell right now. Number of jelly beans guessed. And then the dependent is how far the guess is off. Okay, so again, this was just an introduction. Hopefully you guys did okay on matching the graphs. Some of them, like I said, are harder than others, and we're just doing the best we can. Okay, we will have more practice with all of these types of graphs later on. Okay,